Good evening, everyone. Can you hear me? Can somebody please confirm?
Yes, sir.
Yeah, thank you. So, myself Shankar Rao, PhD scholar from the Department of Electrical Engineering, IIT Hyderabad. So, today we are going to discuss about jet transforms, and I think in another session, jet transfer were covered, right? Were they covered? Hello. Other session, jet transfer were covered or not? Fine. Let us see some of the basics of the jet transform, then we will try to solve the problems. You know, the jet transform is generalization of DTFT. You know, right? Jet transform is generalization of DTFT, discrete time Fourier transform, right? Okay. Actually, DTFT is defined for only stable signals. So this is defined for only stable signals. So if the signal is unstable, then DTFT cannot be defined, but jet transform is defined for stable as well as unstable signals. Okay, and jet transform is a counterpart of Laplace transform. You might have seen Laplace transform, right? So it is discrete time counterpart. Laplace transform. So Laplace transforms, continuous time Fourier transform is defined for non-periodic and continuous signals. So only that is defined for stable signal. So generalization of CTFT is Laplace transform. This is for continuous signals. So its discrete time counterpart is what? For CTFT, discrete time counterpart is DTFT, discrete time Fourier transform. Its generalization is jet transform, right? So let us say if we have some signal x of n, a discrete signal, then you know, right, the jet transform of the signal is defined as sigma n equal to minus infinity to plus infinity x of n z power minus n. So this is nothing but the jet transform, right, of a signal. So here z is nothing but r e power minus j omega. Okay, suppose in this if I replace instead of z r e power j omega, then it will become sigma n equal to minus infinity to plus infinity x of n into, it will become r power minus n and e power minus j omega n. So we know DTFT we know, right? So if you take this as some signal, a single signal, so this is nothing but the DTFT, right? Discrete time Fourier transform, right? So we know DTFT of a signal x of n is what? Sigma n equal to minus infinity to plus infinity x of n e power minus j omega n, right? So this is nothing but what? DTFT of, so it is DTFT of x of n into r power minus n. Okay, so jet transform is nothing but discrete time Fourier transform of x of n into r power minus 1. So if I draw a z plane, so since z is r e power j omega, so let us say this is real part of z, this is imaginary part of z, and this is 0, and this is a unit circle. That means whose radius is 1, whose radius is 1. This is called unit circle. This is called z plane. Okay, if r equal to 1, if I take, if r equal to 1, if I take, that means z equal to e power j omega. So in this, if I replace r equal to 1 in this definition, you see here in this definition, if we replace r equal to 1, so what will happen? It is same as DTFT, right? It is same as DTFT. In this r equal to 1, if I replace, it is nothing but DTFT. So r equal to 1 means radius on the unit circle, that is jet transform calculated on the unit circle is nothing but the DTFT, discrete time Fourier transform. Okay, so jet transform calculated on unit circle. So for r equal to 1, that is on unit circle, jet transform is nothing but the discrete time Fourier transform. You might have seen in Laplace also, right? S equal to sigma plus j omega, right? Your Laplace domain, if you take for continuous signals, this is sigma and this is j omega, real part of s, and imaginary part of s. This is called as plane. And so j omega equal to 0. This axis, this vertical axis is nothing but sigma equal to 0. This axis will say sigma equal to 0. And here this unit circle is r equal to 1 is nothing but the unit circle. Okay, so this sigma equal to 0 axis is the counterpart of unit circle. Okay, so if we take sigma equal to 0, then s equal to s becomes j omega. Then Laplace transform is nothing but the continuous time Fourier transform. Okay, so this j omega axis corresponds to the unit circle in the jet plane. Okay, and this upper half axis is nothing but the upper unit circle, like half of the above that upper unit circle, and this one is nothing but the remaining unit circle. Let us say this is 0, this is pi by 2, this is pi, this is, let us say, minus pi by 2. So from this imaginary axis from 0 to plus infinity is nothing but the unit circle 0 to pi, discrete to continuous. So this relation is required when we are like translating continuous domain continuous signals to discrete signal. So this relation is required. So hope you understood this one, Z domain representation. So now in this definition we have seen x of z is this one, right? X of z is this one. Now the values of z for which this x of z or this whatever this equation is defined, that is nothing but the ROC, region of convergence. You might have seen in Laplace domain also, region of convergence, right? So in the similar way, what is the region of convergence? Let us say x of z z transform of a signal is this one. Then for what values of z this is valid, this equation is defined, that is nothing but the region of convergence. So here it is a summation, right? So here it should be absolutely summable. So n equal to minus infinity to plus infinity, it should be, this entire thing should be a finite quantity, it should not be infinity. So the values of z for which this condition is satisfied, that is nothing but the region of convergence of z transform. Okay. So this DTFT is defined only for stable signals, but Z transform is defined for stable as well as unstable signals. Suppose let us take one example like how Z transform as well as region of convergence is calculated. Just I'm taking one example. So let us say x of n we have some a power n u of n, let us say, then Z transform for this is x of z is sigma n equal to minus infinity to plus infinity. X of n is a power n u of n into z power minus n. Now since it is u of n, so this signal is nothing but a power n for n greater than or equal to 0. It is 0 else, right? So this is from n equal to 0 to infinity a power n. U of n is 1 for n greater than 0, z power minus n. So this I can write like this. So a z power minus 1 whole power n. So this is something like this, right? 1 plus a z power minus 1 plus a z power minus 1 square, so on up to infinity terms. So this is absolutely summable only when this integration, sorry, this summation can be possible when it is absolutely summable when this quantity is less than 1, right? The magnitude of this quantity less than 1, then only it is absolutely summable. If it is 1 or greater than 1, then it will be infinite. Then Z transform, so it will be infinite, right? So we cannot find out the Z transform, right? So this is the condition. For this condition only we can find out the Z transform. That means it is this summation is absolutely summable. So sum of n terms in GP, this is nothing but 1 by 1 minus a z inverse. So this is the Z transform for this. Now what is the ROC? So when this is defined, when we are able to calculate Z transform, the condition is this one. The magnitude of this is less than 1, then only we can absolutely sum this. So from this we can write, so mod Z greater than mod A. So this is the ROC for this Z transform. In this way we will calculate the ROC for the Z transform. So just like you have seen many other properties, so for Z transform also we have like different properties. What we will do, we don't discuss the properties now. We will see some of the problems when and when the properties are required, we will just touch upon the properties. Okay. Is that okay? Any doubts in this? There is some introduction about Z transform. Okay, fine. Thank you. Uh, Now this question was given, just 1 minute. Now this question was given in GATE 2015 set 1 uh, for 2 marks. So this is the question for the discrete time system shown in the figure. the poles of the system transfer function are located at. So this is a kind of block diagram or signal flow graph that is given. Okay, so input x of n, you can say this is system. So this is the system and output is y of n. So first we need to find out the system transfer function. They're asking the poles of the transfer function. You know what is the transfer function, right? Suppose we have some system. If we have, okay, so let us say x of n is the input and output is y of n, okay, and the system impulse response is, let us say, h of n. Let us say I'll talk about in z domain. So input z transform of input signal is x of z, and z transform of this impulse response is h of z, and z transform of output is y of z. Then the ratio y of z by x of z. So this is equal to h of z. This is nothing but the transfer function. Okay, transfer function is nothing but z transform of the impulse response. Okay, z transform of the impulse response is nothing but the transfer function. Now for this, so what are the poles? You know, poles means if we have some transfer function in this form, so p of z by q of z, then the values of z at which q of z becomes 0 is nothing but the poles. Similarly for zeros, where the numerator polynomial becomes 0 is nothing but the zeros, right? The value of z for which the numerator polynomial becomes 0 is nothing but uh, uh, zeros. Now we will find out the transfer function for this system now. Fine. Now let us say we have some signal, let us say x of n, and it is passing through some system whose transfer function is z inverse. Then the output of this is nothing but delay. Okay, so this corresponds to what? If this introduce a delay in the input signal. Okay, you might have seen this property of z transform, that is if x of n is having z transform x of z, then x of n minus n naught will have z transform z power minus n into x of z. Okay, so what is the output in this case? What is the output? X of n, let us say x of n z transform is x of z. So then what is the output z transform? So what is output? Output, let us say y of z is nothing but x of z into h of z, right? So y of z is what? Input is x of z into z inverse is the transfer function. So this is nothing but what? Using this property, if I take inverse z transform, if I take, so what I get? The output is nothing but x of n minus 1, right? Okay, so this z power minus 1 introduces 1 unit delay in the signal. Is this clear? Okay, now if you see here in this, okay, now in this, if you consider, since it is y of n, you see here, this is y of n. Now this y of n is passing through z inverse block, this block. Now what is the output of the z inverse block? that y of n is delayed by 1 unit, time delay, y of n minus 1. Now again this y of n minus 1 is passing through the second Z inverse block. So here again it will be delayed by another unit. So it will become y of n minus 2. Okay. Now what is the output of this block here? So minus 1 by 6, it's a constant. So it will be multiplied with minus 1 by 6. So minus 1 by 6 into y of n minus 2, output of this block. Similarly, this y of n minus 1 is given as input to the 5 by 6 block. So output of this block is what? 5 by 6 into y of n minus 1. Okay. So y of n is first passing through this delay unit Z inverse. So we'll get y of n minus 1. Again passing through another delay unit Z of n minus 2. Y of n minus 2 you'll get. Now what is the output here? At this, let us say this is some y1. So what is the output here? X of n. Since there is this summing block here, right? So this is nothing but x of n minus 1 by 6 into y of n minus 2, right? And again after this summing block, what? So let us say this is y1 of n. So y1 of n is what? Since there is a summing block, x of n should be added to the minus 1 by 6 y n minus 2. Similarly, the output, let us say final output is what? Y of n. Y of n is nothing but what? y1 of n plus 5 by 6 into y of n minus 1. Okay, that means here what is output? X of n plus this signal plus this signal, all three are added because two summing points are here. So all are added. So final output y of n is nothing but what? X of n minus 1 by 6 into y of n minus 2 plus 5 by 6 into y of n minus 1. Okay, this is our y of n. So now we need to find out the transfer function. To find the poles, we need to find out the transfer function. So what I will take? I will take Z transform on both the sides. So left side Z transform is, so this one. So left side Z transform is what? Y of Z. And right side X of n, let us say Z transform is X of Z. And minus 1 by 6 into, using this property, just now we have seen this property. For x of n, x of z is the z transform. Then if input is shifted by an amount of n naught, then its z transform is z power minus n into x of z. Using the property, I am just writing out here. So z power minus 2 into y of z plus 5 by 6 into, next one is what? Y power minus 1. So that's why z power minus 1 into y of z. Now to find out the transfer function, you take all y's aside and x aside. So z power minus 2 minus 5 by 6 into z power minus 1 equal to x of z. So we need to get in this form. Transfer function is nothing but output z transform by input z transform. So y of z by x of z, what we get? 1 plus 1 minus, sorry, 1 1 minus 5 by 6 z inverse plus 1 by 6 z power minus 2. So this is nothing but our transfer function. If you see here, what are the poles? So this is the denominator. We got the transfer function. Now at what values of z the denominator becomes 0, that is nothing but the poles, right? So when the denominator becomes 0, we need to find out the factors for this. Poles means denominator made equal to 0, this you know. So this you can split, I think, minus 1 by 2, 1 by 2 z inverse into 1 minus 1 by 3 z inverse equal to 0. So if we equate to 0, so z equal to 1 by 2 and 1 by 3 you will get. So these are the poles for this. So option C is the correct option. 1 by 2 and 1 by 3 are the poles. Is that okay? Fine. So here what we need to we should know is from this time shifting property of Z transform, this one, yeah, time shifting property of Z transform. Okay, a Z inverse block means it introduces 1 unit of delay in the time domain. Okay, so based on that we are trying to get the expression for output. Okay, then we are finding out the transfer function and we are finding out the poles. Okay, we'll go to the next problem. Yeah, this is the problem. So this problem was given in GATE 2014 ECE set 3 for 2 marks. So let H1 of Z and H2 of Z are given, and H of Z is sum of these two, H1 of Z plus R into H2 of Z. So the quantities P, Q, R are real numbers. Okay, and P and Q are given and R is less than 1, mod R less than 1 is given. So if the 0 of H of Z lies on the unit circle, then R equal to dash. Okay, now so H1 of Z and H2 of Z is given, so we need to find out H of Z. So H of Z is H1 of Z plus H1 of Z is this one plus R into H2 of Z. H2 of Z is 1 minus Q Z inverse power minus 1. So what we get here is 1 by 1 minus P Z inverse plus R by 1 minus Q Z inverse. So what they have given is the H of Z, 0 of H of Z lies on the unit circle. That means we need to find out the 0 of H of Z. So just take LCM and find out the transfer function. So what we get is 1 minus Q Z inverse plus R 1 minus P Z inverse. Okay, now we need to find out the 0. So what is the 0? This one, right? Where it will become 0, that is nothing but the 0. So 0 means the value of Z where the numerator becomes 0. For finding 0, so numerator you made it equal to 0, Qz inverse plus R into 1 minus, sorry, Pz inverse equal to 0. So this is 1 plus R minus Q plus PR into Z inverse equal to 0. So from here what we get, Z equal to Q plus PR by 1 plus R. Please correct me if I am wrong. Simplification. So 1 plus R. Okay, this is the 0 of this. Now, in the problem, it was given if the 0 of h of z lie on the unit circle. That means if this is the z plane and this is the unit circle, the 0 anywhere on the unit circle, it will lie. Okay, that means mod z should be 1, right? So this is the option, like mod z should be 1. So from here you can say z can be 1 or minus 1. So from here what you can say, find out the mod z here. So mod z here, since it's a real quantity, all real numbers clearly it is given. PQ are real numbers. So clearly it is given PQR are real numbers. So mod z equal to 1 is nothing but the unit circle. Since all are real, it can be at plus 1 or minus 1. 0 can be at plus 1 or minus 1. Okay. So Q plus PR by 1 plus R. Either it can be 1 or Q plus PR by 1 plus R. It can be minus 1. So P is 1 by 2, Q is 1 by 4, it is given. So Q is 1 by 4 and P is 1 by 2 equal to 1 plus R. From here half R equal to minus 3 by 4. So R equal to minus 3 by 2. And another possibility is 1 by 4 plus 1 by 2R equal to minus 1 minus R. So this is 9 by 4, sorry 5 by 4 equal to minus, sorry, minus 3 by 2R. So R is minus, sorry, I think somewhere we did something wrong. So, so two values we got for R. I think somewhere we gone calculation mistake. So we need to find out R. So one condition they have given is mod R less than 1. So mod R less than 1 is possible in this case. So in the question it is given mod R less than 1. So here this is not possible because mod R here is 1.5. This is not possible. The other one is mod R is minus 5 by 6. This is the procedure. I think maybe we have gone somewhere some calculation mistake. Is that correct? Just let me check the answer. Fine. I think this is correct only. There might be like this is the procedure. There may be some calculation mistake, but two values we're getting for R. So one is valid and another one is invalid because the condition was given in the question is mod R less than one. So second one is satisfying. First one is not satisfying. Is that okay? The procedure is okay. Fine. Thank you. We'll go to the next question. Yeah. This is another question that is given. So the jet transform of the equation, this is given in GATE 2014 set 3 for 2 marks. The jet transform of the sequence x of n is given by this with the region of convergence mod z greater than 2. Okay. So x of 2 we need to find out for this. Okay. So jet transform is given. So we need to find out to x of n we need to find out for this. Then x of 2 we need to find out. So we are given with jet transform. So we need to find out the inverse jet transform. So then we will get x of n. Then in this x of n, you replace n equal to 2. Then we will get the answer. Right? And also for finding out the inverse jet transform, they have given region of convergence. Okay. So just some time back we have seen. Suppose if this is the signal, so x of n is a power n u of n. So that means it's a right-sided signal. For n greater than or equal to 0, the signal exists, right? So it is right-sided signal. Okay. Now what is the ROC we got? Mod z greater than mod a. So ROC what we got is mod z greater than mod a. So ROC is like outside the particular pole. So let us say in jet plane, if we have somewhere here mod a, let us say somewhere here, then ROC is what? Outside of this pole. So ROC is outside of the pole. So for right sided signal, so if we have x of n is, let us say a power n u of n, then it is a right sided signal. Its ROC is mod z greater than mod a, and its jet transform is 1 by 1 minus a z inverse. So this also we can write z by z minus a. Similarly, let us say if we take left sided signal, later you can try this. So if x of n is minus a power n u of minus n minus 1, that means it exists only for n less than or equal to 1. Sorry, n less than or equal to minus 1. Okay, this is called left sided signal. So for this also z transform is z by z minus a only, but ROC changes. ROC is mod z less than mod a. So for left sided signal, ROC is, let us say a is the pole. So if you draw a circle inside that one, ROC is inside that pole. Okay. So now in the question, they have given region of convergence is mod z greater than 2. So our signal definitely a right sided signal. Okay. Since if you see here, for a power n u of n and for minus a power n u of minus n minus 1, for both the signal z transform is same. So z transform is z by z minus a. Z transform is same, but ROC changes. So based on the ROC, while finding the inverse Z transform, whether this one or this one, we should get confirmed. Okay, based on ROC. Now we need to find out the inverse jet transform. We can use like two ways we can find out the inverse jet transform. One is differentiation principle we can use, or else convolution we can use here. So we know the convolution property of jet transform, you know it. Suppose if you have two signals, x1 of n and x2 of n, convolution in the time domain, then its jet transform is product in the z domain. Okay, so x of n, its z transform is x1 of z, x2 to x2 of n, x2 of z is the z transform. Then the convolution time domain becomes product in the z domain. So I can write this one, our signal x of z is given, so I can write like 1 minus 2 z inverse into 1 minus 2 z inverse. So product of two signals I can write. You know, inverse jet transform of this is, since a power n u of n, jet transform is what? 1 by 1 minus a z inverse. Just now we have seen when mod z greater than mod a, right? So similarly here, this is the signal. So what is the jet transform? No, sorry, inverse jet transform for this? So a power n, 2 power n into u of n. Similarly for this, 2 power n into u of n, there is a convolution between them. This is actually our x of n. Okay, this is actually our x of n. So as I said, first we need to find out inverse jet transform. From that we'll find out x of n. Then n equal to 2, we'll get the answer actually for this. So you use the convolution property and find out the inverse jet transform. Then x of n we got this one, 2 power n u of n convolved with 2 power n u of n. So again we need to find out the convolution. So convolution we know. So x of n convolved with h of n sigma k equal to minus infinity to plus infinity. This you know. X of k h of n minus k. In the same way for this, what is the convolution? So sigma k equal to minus infinity to plus infinity. X of k is 2 power k u of k, and the other one is 2 power n minus k and u of n minus k. Okay, this is nothing but our x of n. Now in this we want x of 2, we want, so x of 2 is nothing but k equal to minus infinity to plus infinity 2 power k uk into 2 power 2 minus k into u of n minus k. So this term will be 0 for k less than, sorry, here 2 will get 2 minus k. This term will be 0 for k less than 1, right? Similarly this term is 0 for 2 minus k less than, sorry, minus 1 here. So we know, right, some u of k equal to 1 for k greater than or equal to 0 and equal to 0 for k less than 0, sorry, less than or equal to here. So based on that, this will be existing only for, so I'm just here. So from this u of k equal to 1 for k greater than or equal to 0. Similarly, this equal to 1 for 2 minus k greater than or equal to 0 implies k less than or equal to 2. That means this entire x of 2 is non-zero only for uh, k greater than or equal to 0. The common is what? This is non-zero for k greater than or equal to 0 and k less than or equal to 2. That means when k is varying from 0 to 2, then 2 power k, u of k is 1 and 2 power 2 minus k and u of 2 minus k is 1. Now k equal to 0, 1 and 2 we need to replace. K equal to 0 if you replace 2 power 0 into 2 square plus k equal to 1, 2 power 1 into 2 power 1 plus k equal to 2, 2 square into 2 power 0. 4 plus 4 plus 4, this is equal to 12. Is that okay? So this problem you can do in different ways. Anyway, firstly you need to find out the inverse jet transform. You need to find out. So different ways you can find out whether you can use convolution property or differentiation property of jet transform. Anyway you can use. So you need to find out x of n. You need to find out. Then x of 2 you need to find out. So what I have done is I have used the convolution property. I have found out x of n. Then again, it's convolution of two signals, 2 power n into u of n, 2 power n into u of n. So then I used the convolution definition, then x of 2. But here, while finding out the inverse jet transform, these kind of signals, you should be careful. What is the ROC? See here. So here a power n u of n for this jet transform is z by z minus r 1 by 1 minus az inverse. Similarly for this left sided signal also same. This is also same 1 by 1 minus az inverse. So for this right sided signal mod z greater than mod a and left sided signal mod z greater than less than mod a. So based on this we need to find out the inverse jet transform. Can we move on to the next question, or do you have any doubts on this? Yeah, fine, thank you. This is another question. This was given in GATE 2015, set 2 for 1 mark. An FIR system is described by the system function, this one, finite impulse response system. The system is what? Minimum phase system, maximum phase, mixed phase, or zero phase. Okay. Suppose if you have an system, that is FIR system or some system, we take stable and causal system. Stable and causal. Stable means, I think earlier also I have explained. Suppose you have h of z, let us say transfer function, and it is having some poles. Okay. Now the stable system means its ROC must include the unit circle. This is the stable. Okay, a system is said to be stable if the ROC should include the unit circle. That means the pole should be all the poles. The pole should be inside the unit circle. Let us say pole is somewhere, then the pole you draw some circle. So ROC is outside of this. So this is the ROC. Okay, the ROC must include the unit circle. Now for a causal system, so this is table. For a causal system, the ROC should be outside of the outermost pole. Let us say uh, for a causal system, let's say this is the unit circle. Maybe that in the transfer function there may be many poles. Many poles are there. The system to be is causal only when the ROC is outside of the outermost pole. So outermost pole is this one. So this is the outermost pole. Fine. Okay. So ROC is outside of the outermost pole. This is the ROC. Okay. For a stable system, the ROC should include the unit circle. For causal system, ROC should be outside of the outermost pole. Okay. So a system is stable and causal only when stable and causal only when all the poles lie inside the unit circle. Then only it is possible a system to be causal as well as stable. If all the poles inside the unit circle means all should be inside. Let us say this is the unit circle. Let us say many poles are there. All are inside the unit circle only. Stable means it should have unit circle, and causal means it should be outside of the outermost pole. So this is the outermost pole. So outside of outermost pole is this one. Now unit ROC is outside the outermost pole, and also ROC is including the unit circle. That is possible only when all the poles lies inside the unit circle. Okay. Suppose if you take a stable and causal system, that means for a stable and causal system, all the poles are by default all the poles are inside the unit circle. Okay, all the poles are inside unit circle. For stable and causal system, if all the zeros anyway poles are always inside the unit circle, that is for sure. So for stable and causal system, all poles are inside unit circle. Now if I talk about zeros for this system, okay, if all the zeros are inside the unit circle, all the zeros are inside the unit circle, okay, then that system is called minimum phase system. Okay, all the zeros are inside the unit circle, then it is called minimum phase system. That means this system will have minimum phase delay. Okay, now if all the poles are outside the unit circle, sorry, all the zeros are outside the unit circle, somewhere here, let us say. Okay, anyway pole should be inside the unit circle only, but zeros are outside the unit circle, then this is called maximum phase system. Okay, all poles must be inside, but all zeros should be outside the unit circle. So this is having maximum phase delay. Okay. Now all the poles are inside, but zeros, some zeros are inside the unit circle, and maybe some zeros are outside the unit circle. Then it is called mixed phase system, or you can say non-minimum phase system. Okay, mixed phase system or non-minimum phase system. So its delay is between minimum phase system and maximum phase system. Okay. Now if we come to the question, when a phase system is described by the transfer function, now we need to find out the zeros for this. So based on the zeros, we will like comment about it whether it is a minimum phase system or maximum phase system. So for this, what are the zeros for this transfer function? I can write like this: 1 plus, sorry, z square into 7 by 2 z inverse plus 3 by 2 by z square, let us say. Okay. So now denominator you make made equal to 0. So denominator equal to 0, denominator of z made equal to 0, then you'll get poles. So 0 comma 0 are the poles. The poles are at the origin, that is inside the unit circle only. Now numerator you make equal to 0. So numerator is z square 7 by 2 z plus 3 by 2 equal to 0. This gives zeros, right? This gives poles. Now, so this is what? Z plus 2 into z plus 1 by 2 now. So, sorry, maybe z plus 3 into z plus 1 by 2 equal to 0, right? So 3 plus 1 by 2, 3 by 2, yeah. So z equal to minus 3 and z equal to minus 1. These are the zeros. Now for this system, if this is the unit circle, if this is the unit circle, two poles are at origin. That means all the poles are inside the unit circle. Two poles at origin and one zero at minus 1 by 2 and another 0 at minus 3. So all poles are inside unit circle, some zeros inside unit circle and some zeros are outside unit circle. So this is what mixed phase system. Is that okay? So minimum phase system means all the poles must be inside the unit circle. That is the condition. All the zeros inside means minimum phase. All the zeros outside is maximum phase. Like some zeros inside, some zeros outside, then it is a mixed phase system. Okay. Now we can see here. So maximum phase, minimum phase, mixed phase, and zero phase. C is the option. Zero phase means it will not introduce any phase delay. Zero phase system means it will not introduce any phase delay. Is that okay? Any doubts from this? Same FIR system filter same. Okay. So FIR filter only we can say FIR system. Filter is nothing but a system, right? So it will allow some range of frequencies and it will block some range of frequencies. Any filter, anything we can. Filter coefficient. I did not get here. No need to worry about filter coefficient here. Based on poles and zeros, we can comment whether it is minimum phase, maximum phase, or anything else. So if you have doubts, you can stay back or else you can join the other session. I think it's already started. Sorry for the delay. Thank you. Thank you, everyone.